Welcome to the Pocket Science channel. We have already covered some parts of integration. If you haven't watched it, please watch it from the link given below in the description. Let's move to the next type of integration. That is the use of partial fractions. By using some examples, I am going to cover this part. The first example I am considering integral 1 upon x squared minus 9 dx. Then I can make this one into partial fractions. Before that, I can factorize the denominator as integral 1 upon here x minus 3 times x plus 3. It is in the form of difference of two squares. Okay, now I am going to break this into partial fractions. 1 upon x minus 3 times x plus 3. We can write it as separately x minus 3 plus x plus 3. At the numerator, I can take a and b. Then, by taking the common denominator, x minus 3 times x plus 3. Here at the numerator, I have a times x plus 3 plus b times x minus 3 is equals to 1 upon x minus 3 times x plus 3. By comparing the coefficients at the numerator of x to the power 1. Here there is no any x to the power 1 term. Then I can write the coefficient as 0 equals to, here it is a plus b. Then by comparing the coefficient of x to the power 0 term, that means constant. Here the constant is 1 equal 3a minus 3b. And if I simplify this further, I will obtain 1 upon 3 is equal to a minus b, the second equation. By solving these two simultaneous equations, here I am adding 1 plus 2. Then I will obtain 2a is equals to 1 upon 3. A is equals to 1 upon 6. Then by substituting it in the first equation, I will obtain b equals minus 1 upon 6. Now I can write the function integral 1 upon x squared minus 9 dx as integral a upon x minus 3. Here a we have found 1 upon 6, then 1 upon 6 times x minus 3 dx plus b upon x plus 3. Here we have found b as minus 1 upon 6, then I can write minus integral 1 upon 6 times x plus 3 dx. Now in here, if I take the constant 1 upon 6 out, you can see the derivative of x minus 3 is 1. It is at the numerator. Then directly you can write it as ln x minus 3. Similarly, for this term, if I take minus 1 upon 6, I am having ln x plus 3 plus c. Then here 1 upon 6 is the common factor. Then if I take 1 upon 6 out, I am having ln x minus 3 minus ln x plus 3. Then altogether I can write ln the ratio of x minus 3 and x plus 3 as x minus 3 upon x plus 3, since there is a negative sign in here, plus c. This is the way of using partial fractions in integration. The next example is integral 3x upon x squared plus 4x minus 5 dx. And before making the partial fraction, I have to factorize the denominator. That is 3x upon, the factors of the denominator is x plus 5 times x minus 1 dx. Now I am breaking this into partial fractions as 3x upon x plus 5 times x minus 1. Then I can write it as a upon x plus 5 plus b upon x minus 1. If I take this x plus 5 times x minus 1 as the common denominator, I am having at the numerator a times x minus 1 plus b times x plus 5 is equals to 3x upon x plus 5 times x minus 1. By comparing the coefficients of the numerator, first I am comparing the coefficient of x to the power 1 term. Then here it is equals to 3 equal, the other side it is a plus b. First equation. Now I am comparing the constant. Here there is no any constant, then 0 equals to minus a plus 5b, the second equation. By adding these two equations, I will obtain 6b equals 3, then b equals 3 upon 6. I can write it as half. By substituting it in the first equation, I am having a equals 3 minus half. It is 5 upon 2. Now I can write the integral of 3x upon x squared plus 4x minus 5 dx as integral a upon x plus 5. Here we have found a as 5 upon 2 x plus 5 dx plus integral b upon x minus 1. Here we have found b as half, then 1 upon 2 times x minus 1 dx. Then here if I take the constant 5 upon 2 out, the derivative of x plus 5 is 1. It is at the numerator. Then I can write ln x plus 5 plus, if I take half out, I can write ln the denominator x minus 1 plus c, where c is the arbitrary constant. The next example, integral of x plus 1 upon x plus 2 all things squared dx. Now let's break this into partial fractions. X plus 1 upon x plus 2 whole thing squared. You know, when expressing this as partial fractions, the way is somewhat different. Here we have to take x plus 2 plus another term x plus 2 with the power 2. When there is power for the linear function, we have to separate the partial fractions by increasing the power 1, 2 and etc. Then here at the numerator it will be a and b. Then by taking the common denominator x plus 2 whole thing squared, here I am having a times x plus 2 plus b. The other side I am having x plus 1 upon x plus 2 whole thing squared. By comparing the numerators, by equating the coefficient of x terms, x to the power 1. Here it is 1 equals to, here the coefficient of x in here is a. Then directly we can obtain a equals 1. Then by comparing the coefficient of the constant, here the constant is 1 equals to, here the constant is 2a plus b. Then we have already found a is equal to 1. Then here 1 equals 2 times 1, 2 plus b. Then b will be minus 1. Now I can express this x plus 1 upon x plus 2 whole thing squared dx as integral a upon x plus 2. Here we have found a as 1, then 1 upon x plus 2 dx plus b upon x plus 2 whole thing squared. I have found b as minus 1, then I can write minus integral 1 upon x plus 2 whole thing squared dx. Then here directly we can write the integral. Here the derivative of the denominator is 1, it is at the numerator, then I can write ln x plus 2 minus, here I can write this as integral of x plus 2 whole thing to the power minus 2 dx. Then here it is ln x plus 2 minus the integral of this one x plus 2 whole thing to the power minus 2 plus 1, it is minus 1 upon minus 1 plus c, where c is an arbitrary constant. Then if I simplify this, it is ln x plus 2 minus times minus, it is plus. Then here this is in the negative power, then I can make it as positive 1 upon x plus 2 plus c, where c is an arbitrary constant. Here the next example, integral of 1 upon 1 minus x to the power 4 dx. First I have to factorize this part. Then this is in the form of difference of two squares, like this, 1 upon x squared whole thing to the power 2 dx. Then if I write the factors, it is 1 upon 1 minus x squared times 1 plus x squared dx. Then I can further factorize this as integral 1 upon this 1 minus x squared as 1 minus x times 1 plus x times 1 plus x squared dx. Now I am going to break this into partial fractions. 1 upon 1 minus x 1 plus x times 1 plus x squared. Here 1 minus x, the denominator is a, plus for 1 plus x the denominator is b. For 1 plus x squared, since the power of x in here is 2, the numerator should be a linear function, it is cx plus d. Now I am taking the common denominator, one minus x times 1 plus x times 1 plus x squared. Here a times 1 plus x times 1 plus x squared plus b times 1 minus x times 1 plus x squared plus cx plus d times 1 minus x times 1 plus x, and here I am writing it as 1 minus x squared, the multiplication of this one. Okay, now I am comparing here. The numerator in here is 1. I am comparing the coefficients of the x terms of both the numerators by equating the coefficient of x to the power 3. In the left side it is 0 equals to, in the right side here it is 1 plus x squared plus x cube. It will be easy if I write the expansion. 1 plus x squared plus x cube. In this side it is 1 minus x plus x squared minus x cube. Okay, now if I equate the coefficient of x to the power 3, here 0 equals to a minus b. On this side cx times minus x squared minus cx cube, then it will be minus c. Then if I equate x to the power 2 term, here 0 equals to, in here a plus b, in here it is minus d. There is no any other terms. If I equate the x terms, here 0 equals again a minus b, here a minus bx, then a minus b, plus in this side c. If I equate the constant, the left side it is 1 equals a, here a times 1, a plus b plus d times 1 d, a plus b plus d. Here there are 4 simultaneous equations and 4 unknown terms. Now if I add equation 1 and equation 3, I will obtain, I can cancel out the c part. Then I will obtain a minus 2 times a minus b equals 0. Similarly, to remove d, I can add equation number 2 and 4. Then I will obtain 2 times a plus b equals 1. Then here a plus b equals to half. Then in here a minus b equals to 0. Then if I add these two equations, I will obtain 2a equal half. Then a will be 1 upon 4. By substituting in this equation, I can obtain b also equals to 1 upon 4. Then by substituting it in this equation, 1 upon 4 minus 1 upon 4, it will be 0. Then c equals to 0. Then by substituting it in the second equation, 1 upon 4 plus 1 upon 4, it is half. Then d equals to half. Then I can write c equals 0, d equal half. You can separately work out this part and apply to the question. Now we can write it as the integral of 1 minus x to the power 4 dx equals to, we have found that it is in the form integral a upon 1 minus x. We have found that a as 1 upon 4. Then you can write integral 1 upon 4 times 1 minus x dx plus b upon 1 plus x. We have found that b also 1 upon equals to 1 upon 4. Then I can write integral 1 upon 4 times 1 plus x dx plus we have found that c is equal to 0 and d is equal to half. Then it is in the form cx plus d. Then there is no any x terms, there is only a constant, it is half. Then I can write integral 1 upon 2 times 1 plus x squared dx. Now it is easy to integrate. See, if I take 1 upon 4, the constant, out, here the derivative of 1 minus x, it is minus 1. Then I can write it as minus ln 1 minus x. It is okay now? Plus, here if I take the constant 1 upon 4 out, the derivative of 1 plus x is equals to 1. Then I can write directly ln 1 plus x. Plus, if I take half out, here it's only remaining 1 upon 1 plus x squared. It is in the form of derivative of tan inverse x. Then I can write directly tan inverse x plus c. Now here I can take 1 upon 4 as common for the first two terms, and if I take 1 upon 4 out, I am having ln 1 plus x minus ln 1 minus x plus half tan inverse x plus c, where c is an arbitrary constant. Here both the logarithmic functions are getting subtracted. Then I can write it as a ratio 1 upon 4 times ln 1 plus x upon 1 minus x plus half times tan inverse x plus c. This is the integral of the question. To get the remaining part of the integration, please keep our channel subscribed. Thank you.